This is Math One's homework help for Tuesday, okay? The study guide. The homework this week is the study guide. So we have study guide. And the Monday part that we were supposed to do was problems 1 through 8, okay? And Tuesday was 9 through 16. So let's look at the first one. The first problem says, which of these statements, let me make sure this is clear. Which of these statements describe the correct method to solve this equation below? Okay, so I'm going to rewrite this. Number one, this is -5. We have x squared equals, x squared plus 6 divided by x. Okay, so now we're gonna divide. We're gonna multiply both sides by x. Yeah, let's multiply both sides by x. That'll get rid of this. That'll get rid of the x on this side, and this gives us -5x here is equal to x squared plus 6. Okay, so now if I'm solving this, I can move this to the other side because this is a quadratic function. So I'm going to add 5x to both sides. So this is 0 now. So now I can solve this. So this is x squared. Then I put plus 5x plus 6. And then I can factor this. Let me look at my answer choices to see what they have so far. All right? Because they don't want to answer. They just want to know what to do. So A says multiply both sides by x. That's true. That's what we did. Set the equation equal to 0. And then factor. Okay, but when you multiply both sides by x, you still can't factor until you move this to the other side. You see, you can't factor till you get to this step. So right idea, but it's missing some stuff. So it's a possible answer, but it is missing a couple things. Okay, divide both sides by x. No, you're not dividing both sides by x. Okay, so this one's not it. Cancel the x in the numerator and denominator, and then no. Cancel. Well, cancel x in the numerator and denominator, then why did they say that? Cancel x. No. So the best answer, even though they are missing a couple things, you do set the equation equal to 0. So in setting the equation equal to 0, you need to make sure that you move the plus to this side. I mean, you need to move the 5x to the other side. So they didn't say it how we would say it or how I would say it, but that's the best answer. Okay. So on my paper, I'm going to put A because that's the best answer. All right, I'm going to move to number 2. Number 2, the height in meters of the projectile involves the object's initial upward velocity and the acceleration because of gravity. And we talked about that today. If the equation, look at this. This is the equation right here, -9.8 t squared, and then this right here, look, 109.7, and then we got, this is the starting amount here. Models the number of meters a toy rocket is above the ground t seconds after being launched. What does the 7.4 mean? That's the initial height of the rocket. You see how that's C? That's your initial height. So number 2 is C. Okay. Number 3, Marcus had a square-shaped garden. So the garden is a square. Okay. That has this as the area. Okay. If the garden has 4 equal sections, what is the area of each section? All right, so let's look at it. Let's factor it to see what each section would be. Okay, let's factor it and see. All right, so we got 4 parentheses x squared minus y. Okay. All right, so each of them, I could look at this. Look, this times itself, is that going to give me this? Okay. So if I square all of this, then yes, it would give me, wait a minute, square feet. All right, let me see. It has 4 sections though. And so we need to divide it. If this is the area and has 4 sections, we need to divide it by 4 to see what we get. Let me see. If the section has 4 equal sections, what is the area? So we need to divide this by 4. So we will take this and divide that by 4. Yeah. So if we divide that by 4, then it's going to equal, these 4 is going to cancel out, and that's going to equal this. Each section is going to be this. Okay. Because then when I multiply this times 4, it gives me this again. So this is going to be my answer. Each section is going to be that. So that answer is B. Because I had to divide everything by 4. This is the area, divide the area by 4 to see what each of the sections each would be. So divide the area by 4, and that's how you get your answer. So number 3 is B. All right. That was a little tricky. Number 4, the function rule A is equal to S squared. That's the formula for the area. A is equal to S squared. This is the formula for area of a square, okay? Let's see, is modeled for area A of a square where the side lengths are S. Which of the following represents another way to write this rule? 2 times S? No, okay. No, not 2 times S. A is equal to A squared? No. No, even if I was, no, that's not it. All right, and then an S, yeah, this is another way. You could write it like this. This is written in function notation, okay? All right, and then A of X. Well, the reason why it's not A of X is because they use the letter S. So if you're going to use the letter S, then in the parentheses need to be S, okay? If you use X, then here needs to be X. So this is the best answer right here. C is your answer, okay? Number 5. A ball is thrown into the air. The graph below shows the height of the ball in feet with respect to the time in seconds. Okay, so look. It says, which of the following statement is not true? The ball is in the air for 8 seconds. So look at this. The ball is still in the air. 8 seconds is over here. Yes, okay. The ball is still in the air. It hits the ground at 8 seconds, okay? So that's when it stopped. That's okay. So that's possible because for 8 seconds it is in the air. The ball is at the same height at 3 seconds as it is at 5. So let's do 3 seconds here and let's do 5 here. Yeah, because it's symmetrical. So this is also true. This is 3 and this is 5. Oops, sorry. You can see that. Look. This is 3 seconds here. This is 5 seconds here. Look, go up to the line. 3 seconds is here. And go up to line. 5 seconds is here. This is the axis of symmetry. And they're in the same place. 3 and 5. Okay. So this is true here. Okay. The ball reaches a maximum height of 40. So look, the maximum height should be right here. And 40 is right here. This is the maximum height. This one is false. Okay. And the last one, like we said, this was true. And the last one says that the ball takes the same amount of time to go up as it did down. So up, 4, down. Yeah, it does. So this is true. Okay. Takes the same amount of time. The middle point is 4 seconds. And it's 4 seconds to get all the way up and then 4 seconds to get all the way down. So yes, that's true. So our answer here is going to be C. So number 5, we're going to write C on our paper. Number 6, what is the domain of the quadratic function? Domain is how wide it is. These are arrows. These arrows are going to go on forever. So remember, the domain of a quadratic function is all real numbers. So that's D. That's all real numbers. Okay. So number 6 is D, all real numbers. Which quadratic function has an intercept? Okay, which quadratic function has an intercepts of 2 and 0 and negative 4 and 0? So we got 2 and 0. So go over 2 and 0 is right here. And negative 4 and 0. Okay, those are x-intercepts. Let's try B. All right, B is not, you see, this is not it. It's positive 2 and positive 4. No. This has no, because it doesn't cross at all. This is no intercepts. No zeros at all, or x-intercepts. And here it's 0 and negative 4. So the answer for this one is actually A. So number 7 is A. Okay. Number 8. A toy rocket is launched from a roof of a building. The graph below shows the height of the rocket X seconds after it is launched. What is the average rate of change of the height of the rocket during its descent? So if you find in rate of change, you're using y2 minus y1 over x2 minus x1. So you know you need 2 points. And they want to know the rate of change from the height of the rocket during its descent. So at what point it starts to descend to when it descends. Okay, so this is the highest point. This is when it starts to go to the other direction. So that ordered pair is, let's see, this is 1 here. Is this 1.5? Is this right? What's this right here? Okay, 1. So 1 comma 64. And when it falls, it's right here, this point right here. So they want to know the rate of change from here to here. And this is 3, 0. So that's how we find the point. The point where it starts to turn around is here. And when it falls to the ground, we just want to know the rate of change for this part from here to here. So this is x1, y1, x2, y2. So this is going to give me, on the top, this is going to give me 0 minus 64. And on the bottom, 3 minus 1. So it's going to give me negative 64 divided by or over a 2. Okay? So when you divide that in half, that's going to be a negative 32. Okay? So negative 32 feet per second. Okay? Negative 32 feet per second. So your answer for number 8 is A. 8 is A. So that's Monday. 1 through 8 was Monday. Okay? 1 through 8 is Monday. So now I'm gonna do Tuesday now. I'm gonna do Tuesday on the same sheet. Tuesday, it's 8 through, what I say, 16. Or I already did 8, y'all. 9 through 16. Okay? So let's look at number 9. A theater sells T tickets at a price of P dollars each. The theater conducts a survey and predicts that if the price of the ticket is changed to $2, the number of tickets sold will change by 15. N is the number of times a theater changes the ticket price by $2. The expression, and this is the expression right here, they give it to you. P plus T, and okay, and then multiply that times N minus 15N can represent the theater's total revenue in dollars. Okay, so now it says in this expression, what does T minus 15 represent? All right, so looking at this, we got P plus 2N. You see how P is, let's see, it says the theater sells T tickets at the price. You see, price of each ticket is P. Okay, so that's the price of each ticket. The theater conducts a survey and predicts the price of each ticket is changed to $2. So we got $P for each ticket plus the $2 is the number of tickets sold by. Wait. Hold on real quick, y'all. Okay. Sorry, I had to get me some candy, y'all. All right, so where was I at? All right, so a theater sells T tickets at the price of $P each. The theater conducts a survey and predicts that the price of each ticket is changed by $2. Okay, so the price of each ticket. Okay, good. The number of tickets sold will change by 15. Okay, so if they go up $2, every time they go up $2, they're going to lose 15 ticket sales. Okay, so if N is the number of times the theater changes the ticket price by $2. Okay, so look, it's saying, what does this part represent? So this part right here represent the remember right here it says the number of tickets, or a theater sales T tickets. So this is the number of tickets sold. So number 9. So we got T. This part of the T of this is just T minus 15N. I'm trying to figure out what that means. This is the number of tickets sold. Okay. Minus. Okay. So this is what you sell, and you're subtracting 15 from it. Okay. Every time they go up by. This is every time they go up by $2. Okay. So every time they go up by $2, they're gonna lose 15. That's what we need to be looking for. So the increased ticket, the number of tickets the theater will sell if the ticket price increases by 2. No, that's a good answer. The number of tickets the theater will sell if the ticket price is increased by 2N. No, not 2N, just $2, okay? The number of tickets the theater will sell if the ticket price is decreased by $15. No, it doesn't represent $15, okay? This doesn't represent $15, and it doesn't represent no. So the best answer is going to be A. So here for number 9 is A. All right, so let's look at 10. All right, the zeros of this quadratic function are 1 and 7. Okay, so to which factor expression? So if I set these equal to 0, which one is going to give me a positive 1 or a positive 7? All right, so the first one, A, if I set these equal to 0, this is, let me go ahead and write it out. X minus 1 is equal to 0, and X plus 7 is equal to 0. So this is going to be, I add 1 on both sides. It's going to be X is equal to positive 1. And I subtract 7 on both sides. So it's going to be X is equal to negative 7. And I'm looking for when they're both positive. So that's not right. A is not right. So let's do B, okay? B, X plus 1 is equal to 0. So when I subtract, X is equal to negative 1. No, they're not. They're supposed to be both positive, right? Both positive. So no B. So C, X is plus 1 again, isn't it? No, that's not going to be right. So let's try D. Let's hope D is right? So we got D. X minus 1 is equal to 0. That's good because this actually means that X here is equal to 1. So that works out. And then X minus 7 is equal to 0. When I add 7 to both sides, yes, that my X value is 7. Both of them are positive 1, positive 7. So D is the best answer. So your answer here is D. Okay, that's your answer for this one. All right, let's do 11. A square has sides of, each side is this. A rectangle is made up of 3 of these squares. Okay? The expression would represent the perimeter. Which expression would represent the perimeter of the rectangle? All right. Okay, so we have to figure out, we said a square, the sides of a square. These are the sides of a square. So that means all the sides, that's number 611. So that means all the sides are the same. This is 2x plus 3. This side is 2x plus 3. And so no matter which way you go, whether it's made up of 3 of these. So you're going to multiply this by 3. Okay, and that's going to be one of, even if I had 3 of these this way. Okay, and so this side, this would be 2. And this will be 2x plus 3. This will be 2x plus 3. Even if I turn it the other way, this way, it's still going to be the same. So this, if I draw my rectangle here, this is 2x plus 3. And this would be 2x plus 3 times 3. So let me multiply 2x plus 3. Let's multiply it times 3 to see what I get this way. And this way, of course. So this is going to be 6x plus 9. So this side is 6x plus 9, and this side is 6x plus 9. And this is 2x plus 3. Okay, do you see that? Sorry. Okay. All right, and it doesn't matter which way I turn it, still, it's going to be the same. Okay. All right, so I got that part out the way. So now I need to figure out which one of these will represent the perimeter. So that means I add all of these sides together. So let's add them all together. So let's add all the x terms first. Okay, this is 6 plus 6, that's 12, 13, 14, 15, 16. So that's 16x when I add all the x's together. Now let's add all the numbers together. This is 9. 9 plus 9, that's 18, 19, 20, 21, 22, 23, 24. So this is plus 24. So I combine all my like terms. So I should get 16x plus 24. That's the perimeter. Okay. All right, good deal. Number 12. Number 12, this is calculator active. Josh is making a rectangle picture frame. The length, so that's how long it is. The length of the frame is to be 5 more than twice W. Okay, so that's our length. 5 more than twice W. Okay. And this side is W. All right, so now it's asking which equation represents the area. Remember, when you do that, turn this over for number 12. And when I draw my rectangle on my paper, this is 5 plus 2W. This is 5 plus 2W. And this is W on the end. That's the width. All right, so now the area, remember, of a rectangle is length times width. So I'm going to substitute. My length is going to be 5 plus 2W, and my width is just W. So when I multiply this together, I'm going to distribute. I'm going to put the W first, okay? So W in the front, and then 5 plus 2W. So that way I can distribute this way, okay? So this is going to give me 5W plus 2W squared, or I can write the 2W squared first plus 5W. Okay, and so here it is right here, D. You see it? So D is going to be your answer. Number 13, it says, what is the, okay, so we got, this is an equation here, and this is an equation here. What is the equivalent form? And we're adding these together. So we're going to combine like terms, right? So this is already simplified. So let me simplify g of x, okay? Because this has parentheses. So I need to distribute and do all that stuff, right? All right, so order of operations tell me to do exponent before I multiply, right? So let's do this first. So we got 2 here, and we're going to multiply this times itself. Okay, you see how I did this? I'm doing this first, this times itself. So we got 4 first, x squared, outer, negative 2x, inner, negative 2x, and last, a positive, negative times negative is positive 4. The 2 in the middle, are you going to combine those? That gives you a negative 4x. Okay? And then lastly, you're going to multiply times the 2. So you're going to do distributive property here. So this gives you 2x squared times a negative, 2 times a negative 4x gives me a negative 8x. And 2 times 4 gives me 8. Okay? So that is this g of x. So now you can add them together. It says add the 2 equations together. That's what this means. So the other equation that you're going to add is the 2x squared plus the 3x minus 1. And I wrote this one first because it came first. F of x came first, okay? Not that it matters because you're adding, but it just came first. So the combined like terms, that's this one and this one. So that's 4x squared. And then this one and this one, when I add, that gives us a negative 5x. And then this one plus this one, they're like terms. So that gives us plus 7. Okay. So that one is this one, A. See that? So A is our answer. All right. That's number 13. Number 14. A ball is thrown upward at a velocity of 16 feet per second, a height of 60 feet above the ground. Let's see. The height of h feet, of a ball t in seconds. Okay, so they gave you the formula. This is the equation right here. Okay, find the time in seconds when the ball is again 60 feet above the ground. Okay, so this is calculated active. So what is the time when your height, your y is 60? So type in the equation. So that's negative 16x squared, and that's plus 16x, and at 60 feet. Okay, so now we want to know when is it at 60 feet again above the ground, okay? All right, so we're going to look at our table. Second graph. Second graph. Second graph. All right, so let me see that? Okie dokie. I forgot to put the negative here. No, it is negative. All right. Wait. No, that's right. So when we do that, it's at 60. Wow. At 1. Gosh, that's quick. Ain't it? 1 is the answer. Oh my God. 1 second and it's back at 60 again. That's crazy, ain't it? All right. So in 1 second it's back at 60. So it's quick. That's moving very, very fast. All right. A wooden board is measuring 12 inches by 8 inches. 12 by 8. 12, 8. Okay, cool beans. It is to be shortened informally along the sides by the length should each side be shortened and reversed wooden board is to have an area of 45 square inches. Okay. So the wooden board is to have 45 square inches. All right. What is the coefficient of x squared? Okay, on this right here. Sorry, y'all. All right. So this one is, okay. Hold on. 12, 8. The area of the whole thing, the area of the whole thing, 12 and 8. And if I shortened it, by a half of an inch in all the way around, 1.5, then that means 12 minus 1.5, 10.5, 8 minus 1.5, and so it would be 10.5 times 7, and that doesn't give me, let's do 2.1. So if I shorten it, if I do 12 minus 2.1, and then 8 minus 2.1, and then multiply 9.9 times 5.9, 58. Okay. All right. Let's shorten it some more. 12 minus 3.19, and then, oh gosh, okay, come on. I'm shortening it every time, and then shorten the 8. 8 minus 3.19, and then multiply these two together. 8.81 times 4.81. Oops, 4.81. When I multiply those together, it's 42. Wait a minute. So if that's 42, then it should be B, right? 12 minus, shorten it. But no, is that on both ends? Yeah, that's on both ends, isn't it? So if it's not just on, it's on both sides. Dang. So this one, 1.5 times 2. So we got to say 12 minus 3 is what we're doing. And then on the other side, 8 minus 3. And so then it's 9 times the 5. That's 45. So it's A. I was like, wait a minute, because it has to be 1.5 here, 1.5 here, all the way around 1.5, 1.5. Okay. So this area would be 45. So it's going to be 1.5. That one works. That is crazy. You're tripping on that one. All right. What is the coefficient of the x squared term? Okay. When the expression is simplified. So we have to simplify that one. This one's 15. Oh, and I forgot to write these down. We did most of those in the calculator, but go back and write 14 is A, and 15 we just found is 1.5 inches. And then 16, we're going, these are most of these calculator active. This one, you can't do this on the calculator, so we're gonna have to, I'm going to use the bottom. Well, yeah, I'm gonna use the bottom so I can have more space. We have 5x squared minus x minus 1. And we got negative, this is minus, sorry. Then we have negative 3x squared minus 2x minus 5. Okay, that's what we have for 16. It's supposed to be 16. Looks like it's 6, but it's 16. Okie dokie. So we're subtracting them. So we're subtracting like terms, this one and this one. So that's 5x squared minus, this is minus, a negative 3x to the second. So this is plus a positive. This gives me 8x to the second. So I did these. Okay. So now let's do this one. Negative x minus a negative 2x. So this is plus a positive, and this gives me a positive 1x. Okay, positive 1x. So now I'm doing this one. Negative 1, and I could have lined them up and did it. That's another way to do it. Negative 1 minus a negative 5. This is plus a positive here, and so this gives me 4. My phone has really been ringing off the hook. All right, so this is going to be a positive 8x squared plus the x plus the 4. Okay, and so for number 16, turn it back, let me see. Dang, where is this? Is this a fill-in? I guess this is a fill-in. Yeah, no answer choices for that. So this is your answer for number 16. Okay. All right. All right, y'all. So this is the end of homework help. Please make sure that you finish the rest of the problems tomorrow for homework, okay? All right. If you have any questions, just let me know when we're in class. Okay.